The problem statement from GATE Physics 2018 reads as follows. For an operational amplifier ideal circuit shown below, if V1 equal to 1 volts, V2 equal to 2 volts, the value of V0 is. Since this is a numerical answer type question, we'll find out our answer and round it off to one decimal place because that's what's required. So the problem said this is an ideal operation amplifier with the values of inputs given, and we need to find the value of output. Now, before trying to solve these kinds of problems, we do some pre-checks. So first is this operational amplifier ideal? The answer is yes. The question itself says that. If the question, even if the question did not say it's an ideal, we'll assume it's to be ideal. Only if the question says that it's a non-ideal, we'll go ahead with a non-ideal one. Second, check if there is feedback. What is feedback? Feedback is when the output node is being connected to any of the input nodes through some feedback circuit. So we can see that the output node V0 here is connected to the inverting terminal here using this 4 kilo ohm resistor. So yes, the answer is feedback is yes. The next question is what kind of feedback? So since the output node is connected to the inverting terminal, we call it a negative feedback. Now, since it's an ideal op-amp, we'll assume that the currents entering to the inputs are 0. Now, an interesting thing happens here. Now, remember we read about that there is an R in. So let's try to put Ohm's law across this Rn. So I'll write V plus minus V minus equal to Rn times I, the current flowing here. Now this current is 0 because it's an ideal op-amp. So we can write V plus minus V minus equal to 0. This gives V plus equal to V minus. This condition is known as virtual short. Why short? Because both these terminals have the same voltage. Why virtual? Because they're not actually shorted using a wire. It's just that due to peculiarity of op-amp, these two nodes will be at the same voltage, and the way to denote is we use a dotted line to connect these two to denote that this is a virtual short. Now I have just read on the circuit here, and I have just written that the values of V1 is 1 volts, V2 is 2. We need to find the value of V0. Now let's assume okay, we saw that this is a virtual short. So if this is grounded, so this potential will also be 0. So let's assume that the voltage of this node is Vx, and I can simply write Vx is equal to 0. Why? Due to the virtual short condition. Okay, now let's try to apply KCL at inverting node. Okay, first let's label some currents. Let's say this current is I1, this current is I2, this current is I, which will be equal to 0. Again, let's say this current is I, which will be equal to 0, and let's say the current here is I3. Okay, yeah, that's it. So let's apply Kirchhoff's current law at inverting node. So what does KCL say? That incoming current should be equal to outgoing current. Okay, so what's the incoming current at this node? This is I1 plus another incoming current is I2. The outgoing current is I. This is the current I plus I3. Note that in ideal op-amp, so this is 0. So we get I3 equal to I1 plus I2. Okay. Now let's try to find the expression for I1. How do we find the expression for I1? I write Ohm's law across 2 kilo ohm resistor, across this resistor. So I can write the voltage drop across the resistor is V1 minus Vx, this voltage drop, equal to the current flowing through the resistor is I1 times the value of resistor, which is 2 kilo ohms. This gives me I1 equal to V1 minus Vx. Now note Vx is 0. We know that due to the virtual short condition. So V1 minus 0 over 2k. So I get V1 upon 2k. Okay, now let's use Ohm's law across 5 kilo ohm resistor. So we can write the voltage drop across the resistor is V2 minus Vx. V2 voltage here, Vx here, equal to current passing is I2 times the value of resistor is 5 kilo ohms. This gives me I2 equal to V1 minus, now note the value of Vx is 0 due to the virtual short. So sorry, V2 minus 0 divided by 5k. So this will be V2 by 5k. Now let's put the value of I1 and I2 in this expression. I'll use a different colored pen now. So we'll get I3 equal to V1 upon 2k plus V2 upon 5k. Okay, so now I can get the value of I3. V1 is given as 1 volts, so 1 upon 2k plus value of V2 is 2 volts, so 2 upon 5k. So that will come out to be 0.5 milliamps plus 0.4 milliamps. So the value of I3 that I get is 0.9 milliamps. Okay, now let's apply Ohm's law across the feedback resistor, the 4k resistor, this resistor. So again I can write the voltage drop is Vx minus Vout. The voltage drop is Vx minus Vout equal to the current flowing through the resistor, that's I3, times the value of resistor, that is 4k. So this gives me Vx is 0, so I get minus Vout equal to the value of I3 is 0.49, so 0.9 into 4k. So the value of Vout comes out to be minus 3.6 volts. So the value of Vout comes out to be minus 3.6 volts. We need to find the value till 1 decimal place, and we have found the value till 1 decimal place. That's the value. The value is minus 3.6. Thank you for listening.